Talking about electric motors now. So electric motors are used for multiple purposes, such as pumps, fans, conveyor belts, for different applications such as crushing, drilling, stretching, and compressing materials. They're utilized for short and long periods of time. Sometimes you want motors to work 24/7, the whole life period will be operating, and then they shut it down and turn the motor on and off again until they never turn the motor off. Other motors have hard stops and hard starts, kind of like motors for elevators. So really, the motors are designed for different applications. You cannot choose a motor and put it anywhere because they're designed for different stuff. They have some of them have speed control. Some of them are designed to have a unique velocity. Say some of them are designed to operate 120 RPMs. Some of them are designed to operate at different velocities based on a controller. And that usually depends on the efficiency and safety that you want to provide. So, electric motors are divided in two types: is synchronous and control speed. So, in other words, motors that always travel at the same velocity. Again, elevator, you stop, start, but when you start, you always operate at the same velocity. And say a compressor that you want to control the speed of the mass flow of refrigerant, you can control the velocity or the RPMs. For the type of motors that you want to control, it's their velocity. You use a drive called speed control, and there are different types. There are the mechanical controls, kind of like for elevators, when you have braking gears for um, control when to stop and when to start. You have electrically controlled, which is when to supply voltage and current. Um, this is to also to start and to stop, but DC applications, you can vary the voltage to vary the RPMs or the velocity. In single phase applications, if you vary the voltage, you just lose efficiency, but it's usually the same RPMs. And the variable frequency drive is the most efficient and the most used fashion of controlling AC motors. One single phase AC motors use the frequency drive. So, what is a frequency drive? Variable frequency drives are systems that convert AC signals into a source of frequency and voltage. It's a really cool system. Is used to power and control single phase AC motors. So the key is to remember that it's going to use frequencies to control their velocities. So the components are: one, rectifiers, which we'll talk about, so that they can convert the AC current into a DC current and be able to control that current. The DC bus, which reduces the DC current, and the inverter, which converts DC current back into AC current. Those are the three main components. So you have your AC power going into your motor, then a rectifier is going to convert your AC into a DC signal, then the bus is going to filter that signal, and then it's going to be used in the control system, and then the inverter is going to take it back to AC to complete the circuit. So frequency drives are usually optional because they're expensive and because they're further controlling mechanisms. Sometimes you only need one velocity, and when you want to stop the system, you just cut the voltage off. But if you want to vary the velocity, then it's when you use a frequency drive. And it's a housing suitable for an environment, so you need to add them to the motor, and you need enough real estate and space for the housing to be able to be attached. And sometimes they can have spikes of dangerous currents because they have to do the conversion of currents, and sometimes they could be amplified. So there have to be some safety standards for those frequency drives as well. So they're very useful frequency drives for communications and for electronic interface and for motor speed and for sensors. They provide dynamic braking or variable speed, which is something that is very useful in many industries. And installing the variable frequency drives is usually according to standards of manufacturers. So you need a supply voltage, you need to maintain a supply current, you need to design a circuit to be able to operate the frequency drive, you need to operate logic, you need to program your code so that you can read, or sometimes they even come with a code and with a controller scheme that will let you um, understand the frequencies and the speed and the voltages that you'll be operating at. In other words, if you want to operate a motor at 60 RPM or 100 RPM, you have to check with the manufacturer and with your variable frequency drive what output is the drive going to give you. Is it going to give you a value of current? Is it going to give you a value of voltage? Is it going to give you a value of current? And then from those variables that you get, how do you map them back to RPM? So it's usually not the case, or if this is the case, it's very expensive. It's usually not the case that it tells you press 1 420, press 2 450, press 3 for 200 RPMs. No, they're a continuous range of RPMs where you in your code and your controller scheme have to tune what particular RPM you want based on a set of voltage and frequencies that you obtain. So again, when you get to install a frequency drive, you have to have sensitive electronics because frequencies are hard to measure and they have um, very specific electronics involved like inductors and capacitors and you want to be able to control those frequencies when you vary the voltage and the current, be able to vary the frequency so that the RPMs vary with the frequency. You have to know that there are magnetic fields that could be creating disturbances in other sensors around you. So you have to make sure that your electric field is not extremely high. And you have to keep in mind that you might need external power or more power coming from your panel board to be able to operate it, the frequency drive. Now, controlling the frequency drive, as we said, has the benefits are that you're going to have operating systems that are more efficient. So if you're in a manufacturing floor, you want your belt to go slow the moment you're painting the car, but go fast at the moment that you're trying to transport it to a different building. So those can happen with frequency drives. Of course, the main output is the speed control of the RPMs. Um, Different types of programmers. You can use a PLC, you can use C++, you can use whatever language you want to be able to access the main functionality of the drive, which is voltage, currents, and frequencies. Once you have those values, you can use a computer to interact with the frequency drive. And usually you need sensors to give you, or probes to give you the values of the current and voltages within the drive. So you can use those to be able to control the frequencies. So the applications are usually in electromechanical systems, for compressors, motors, belts with a motor that is going to control the velocity of the belt. For they usually controlled with external computers or with PLCs, as we said. The control mechanisms could be within a box that is part of the drive. You can buy those already with a box. They use a knob to increase or reduce the velocity. But those are not as efficient as having it in a computer, where you, with a mouse, or with your keyboard, can ask the controller to give you more speed or reduce the speed. Another very common application is, as I said, compressors, where um, you want the temperature of the building to be controllable or temperature in your refrigerator. And then by giving you more mass flow of refrigerant, you can get colder temperatures in an instant. Or if you want a water pump, then you can vary the speed of the pump or the pumping by varying the pump velocity with a drive. So there are many applications where you use those systems, and it's up to the operator to be able to operate it at the right conditions. Because then you still have to figure out what is the right pumping pressure, or what is the right mass flow, and those are solved with other types of problems, more engineering problems, but the application is with a very efficient drive that will let you switch velocities with a frequency drive if you're using AC one single phase current. A very common example is in the food industry when they're canning food, they're sealing food in cans, and they have a sensor to determine the speed, and they want to vary the speed of filling the cans. So a belt can go faster or lower, and of course the sensor will be tuned to the velocity to be able to capture the can passing through the sensor, and you can vary your production time with the velocity of the belt and the amount of cans that you can read per minute, etc. All those processes that can be tailored to have different timings are usually underneath. You would have motors and applications with frequency drives that can change the velocity or the speed of the process. So remember, if your process is DC, this is one thing that I keep saying, if your motor is DC, you simply have to focus on changing the voltage. Higher voltage, higher velocity, lower voltage, lower velocity. But if your process is AC, which is probably going to be because moving a motor that can, move a car, so if you put a Toyota, a car in a manufacturing plant, that car is going to be very heavy. You need very strong motors to move that conveyor belt. In order to move that belt, you need a strong motor. So a DC motor is probably not going to help you versus a AC motor will probably be able to give you that amount of power. So again, to be able to control the AC motor, you will use a frequency drive, a variable frequency drive, or they're also called a drive. And in this particular application is a combination of sensors and the drive with a motor. You can tailor the speed of your process in a manufacturing plant or in a food processing plant. The drive usually comes or is usually installed with a combination of sensors because you want to make sure that you can sense how many parts are going per minute so you can decide if you want to go faster or slower, or you can use a proximity sensor to know when you have to open a valve uh, to let paint go through a nozzle or to be able to extrude food in a container. You need switches to be able to turn off and or to actuate on and off a process. You need pressure sensors to make sure that in an injection molding factory that you're making plastic cans and the plastic injection is being done at the right pressure. Timing switches to make sure that you have the right timing between the first can and the second can, otherwise you'll be missing the target completely. So the drive are important to control the velocity of your process. But the other part of the sensors, which we'll talk about sensors later, these words, sensors are important to be able to control the rest of your system.